have learned from during this time is that we are not, the volume is not the most important issue here. The most important thing here is that how you cooperate and how you have added value to your partners. What we have seen a couple of years during COVID time, a lot of supply failure to supply, and how you supply that, and that's where we want to focus as CellMark. And what happened, what we have done in this year is we have been supporting our partners. Now we have own vessel, 30,000 deadweight, to carry out pellets. We also started the logistic business in Q1, and now we're trading every month around 2 to 3 vessels, 40 to 60,000 tons of PDMT, and we're about to trade the PK vessel. That's what we want to be. We want to focus on support and supply and our customer to have more value and to sustain this supply chain during difficult times. But today, the main topic that we are here is to present our new product, and we believe this is some new solutions that some of our end users might need, and this is something we also to help to supply to differentiate themselves from just normal pellet supplier and competing in the same raw materials. So Jake, please have your presentation.
In the past years, we helped our customers to solve clinker problems with the product named Cayman. And now 67% of IPP boiler that uses biomass fuel, the electricity generated is from the ones that use Cayman. So today we would like to share what we learned, what we experienced, what we tested and improved in solving clinker problems in biomass boilers, so that you don't have to go through the same trials and errors that we have been through. And I hope this presentation helps those who need solution but doesn't know where to begin. So back in the days, a few years ago, we had customers suffering from what we're seeing now. It was the time that power producers were starting to use biomass fuel instead of coal, and we didn't know as much as we do now, but it was evident that this was a problem that needs to be solved. To fix the problem, we focused on the core cause of this problem, and we found out that it had multi-layers with the alkali metals such as potassium, sodium, and those were the key factors in layer structure. When the biomass fuels are combusted inside the boiler, the alkali compounds are vaporized into the fuel gas. They're very sticky because their melting points are lower than the boiler temperature. And they act as a glue to put ash particles and bad materials together. And we call this phenomenon agglomeration. And this is one of the problems that causes malfunction in the boiler. Similar to this, when the alkali compounds stick onto the metal surface of the boiler, the ash particles grow on top of it, and this process is repeated over and over again to eventually form a multi-layer that we call slag. And these alkali compounds and ash particles are stuck onto the water, the surface of the water pipe. We call this fouling. So what we saw from our customer boiler was the combination of this agglomeration, slagging, and fouling. They're all distinguished scientifically, but they're all identical in the point that alkali compounds that have low melting points are the cause of the problems. So we needed a name that can represent all these problems at once. So we're calling it Clinker. And ever since, our mission was to make Clinker zero from our customers' boiler. So we know our problem, how to handle it. The regular maintenance can be intuitive option. It is most accessible. But the drawback to this is that you have to shut down the boiler for days and weeks. And every non-operating hours counts toward the reduction of power generation, eventually the revenue. So we needed a solution that does not require shutdown of the boiler. How about if there's a way that we can take the problems out of the field directly? In this case, a pre-treatment can be an option. Leaching is an effective strategy. Research shows that by just immersing biomass fuel into a water container, sodium, potassium, chlorine were depleted significantly. But the downside of this method is that you have to construct a gigantic water container and put the fuels in, take them out, and dry them before usage. So this can be effective but not profitable. So we need a solution that not only doesn't require the shutdown of the boiler, but is profitable. The solution we found was in additive. By using an additive, you don't have to shut down your boiler. You can use the fuel in the form as it is. So we decided to use additive, but which one we start with? Back in the day, biomass power generation was not so popular. There were additives for coal boilers, and one of the most popular was the magnesium-based additive. So now we just apply the same to the biomass boiler. It didn't work because the mechanisms of clinker percolation were different. So we needed a solution that could prevent alkali compounds from melting inside, and also a function of discharging so that they can be discharged out of the boiler in the form of ash. So we developed a product that could do both of these functions. And its base is in aluminosilicate. When aluminosilicate, represented in blue sphere here, is put into the boiler, they absorb these alkali compounds, so they cannot melt and stick around. What it also does is that it chemically reacts with these alkali compounds, so that it formulates a high melting temperature substance called cosylite and lucite, which has a melting point over 1500 degrees Celsius, way more than boiler temperature. So they're discharged out of the boiler rather than causing trouble system. The main functions of these aluminosilicate additives are at prevention of melting and discharging. And these functions are governed by its abilities in absorption, chemical reaction, and flowability. And these abilities can be quantified by measuring surface area, alumina-silica ratio, and particle size. In other words, you can evaluate the performance of an additive even before you put it into your boiler and see if it works or not. So if you have an additive with a large surface area with the golden alumina-silica ratio and the right size of particle, you know it works. And some of the aluminosilicates are probably familiar to you. Fly ash is an aluminosilicate, and kaolin is also a natural occurring aluminosilicate. There are customers asking if our products are either fly ash or kaolin, and their answer is no, and you're about to see why. The surface area of fly ash is 0.3, and the unit is in square meter per gram. The kaolinite has a surface area of 18.1, according to research. The thing about kaolinite is that it contains the water of crystallization at the temperature around 700 degrees Celsius. Loses water to become metakaolinite, the upgraded version of the kaolin. It has a surface area of 28.1. It's not bad, but Cayman has a surface area of 139.8. And this is our quality control line. Another factor that affects the performance of an additive is the alumina-silica ratio. This chemical equation basically says that we use aluminosilicate to react with alkali compounds to form cosylite that has a high melting point. And I'd like to focus on the part that 1 mole of alumina react with 2 moles of silica to form cosylite. If you apply a molar weight on this, you get the ratio 0.002. And this is the golden ratio to form customized. So we can say that it's not about the content of alumina that governs the performance of an additive, but it's the balance between content of alumina and content of silicon. And unlike the two previous standards, there's no concept of superiority in particle sizes. All boilers have different sizes, flow rate, pressure, structure. So there's only a particle size that is most suitable for each boiler. It's just that if the particle is too large, it will not flow well. If the particle is too small, it will be sucked out and escape through EP, electrostatic precipitator. So it's about how well you can customize the particle size suitable for the customer's boiler. So how did it work in actual boiler? This is SGC Energy, the largest power producer, biomass power producer in Korea, both in public and private sector combined. They generate more than 400 megawatts of electricity every hour just from biomass generation. They use more than 1.3 million tons of wood pellets every year. Today, we would like to share the case that we applied our aluminum silicate-based additive in biomass boiler of SPC Energy from the development stage. When we first applied Cayman to biomass boiler of SPC Energy, it was very important for us to see if our product works or not. So we evaluated the performance of additive by measuring the abilities from the ash data on a daily basis. The blue curve is the alumina content in ash. It goes up when more Cayman is put in. It goes down when less Cayman is put in. And the orange curve here represents the AC index, which is basically the alkali compounds found in ash, which is discharged out of boiler. So if these two curves move in the same way, it means Cayman is working fine. If they move independently, Cayman is not working. And we have this coefficient of correlation that was found to be 0.86. If it is closer to 1, they're related. If it is close to 0, they're not related. So we have this number, 0.86. It means that Cayman was performing very well. A picture worth more than 1,000 words, so we prepared one. And this is during the regular maintenance after a month of application of Cayman. And a video worth more than 1,000 pictures, so we also prepared one. We were not able to find a single trace of clinker. And even the part that looked like a dust is a sunken ash, it's not a clinker. You can see that they're easily shaken off. It's a rare opportunity to have a chance to share this video like this that can be sensitive. Thanks to our partner, SGC Energy, for such a great favor. After applying Cayman, SGC Energy never had to go through a single clinker in this shutdown. And this directly increased the revenue through more power generation, which worth up to $14 million US. So today we went over how we developed our product, Cayman, and we shared our footprint in solving clinker problems. If you draw a business 101 axis with the comfortableness and effectiveness graph like that, it will look something like this. And over the past experience, we learned that there were biomass boilers that does not have an additive feeder. They have a clinker problem, but they didn't have an additive feeder, so they were not able to apply additive to their boilers. So they have to suffer from these problems. And it is our mission to solve problems in biomass boilers. So we wanted to develop a product that is very effective, but way more comfortable so that anyone can use, whether you have an additive feeder or not. And we wanted to develop a product that is right up there. And it was not achievable with our own infrastructure until we collaborated with CellMark. As you all may know, CellMark is a global supply chain services company with plus 70 offices in plus 30 countries. Their annual revenue is more than $3.7 billion US. Their value chain ranging from Vietnam, Malaysia, Indonesia, Thailand, Korea, and even here in Japan. Their value chain elevated the technology that blue ocean industry have to invent a whole new product, which can be next generation clinker preventer. I'd like to introduce Clinker Zero Series, a fuel integrated type solution. The powerful additive combined with the fuel in the manufacturing stage, even more effective because we don't have to worry about the mixing process inside the boiler. You don't need a separate additive feeder, of course. You don't need a side oven as well. And we can free power producers from the extra management work. Not only that, for the convenience of the customers, their option, their choices should not be limited to just one or two. So CellMark and Bluocean, starting with Clinker Zero Wood Pellet and Clinker Zero PKS, we're not stopping our effort to explore what's in the future. 15 years ago, I was carrying an MP3 player and around because I like to listen to music. I also had this 2G phone, so I had to carry them both in my pocket. These days, no one carries an MP3 player. They still listen to music, but a smartphone plays the music for you. So 15 years later, there can be a chance that people does not carry on additives and wood pellets altogether because there's a Clinker Zero series that do what should be done. I'd like to close this presentation with the old quote from French mathematician Francois Viette. There's no problem that cannot be solved. We agree. There's only a problem that is waiting to be solved. The CellMark and Bluocean industry never compromise in front of problems of our customers. So we believe that Clinker Zero series can be a next generation product that can contribute to the biomass industry. And until the biomass industry is free from all problems, will not stop our efforts. And thank you very much for your time.
Thanks very much, Jake and Tan. Do we have any questions from the floor, please? Jake, are you currently shipping the pellets, or is it still very much an R&D process?
Well, we were successful in producing a prototype, so it is ready to ship. Okay.
So, are there any utilities trialing it at present, or you're not able to disclose that? Are there any utilities currently running trials with the product?
When Steve Jobs was introducing iPhone, it was not sure yet, so we are introducing our product first time here. So yes.
Very good. Excellent. That sounds like a pretty interesting product actually to see how it goes.
With the help of them, yes.
Okay. Oh, we have a question. Okay.
ディスコさん、カートと申します。非常に面白いアディティブで、興味がありました。できればそのコストとどのくらいブレンドするのかとか、そういう情報を教えていただけるというふうに思います。
I heard a part of the cost, right? So this is about the price.
So, yeah, so,
I don't know the translator, but if this is about the price, the fuel ratio, the percentage, it really depends on the target boiler. Usually, it depends on the grade of the wood pellet, and we analyze the content of the wood pellet, and we think the potassium and sodium are the key factors. So if your fuel has a high content of this alkaline compounds, more K should be cleaned. If less K should be cleaned. So it really depends on which fuel you want to use and which boiler you want to put in. So it really depends on the variables. What I can say is that
Do we have any other questions? Okay, thank you very much, gentlemen. We'll move on to the next presenter for this afternoon, Mr. Ross McKenzie.